First point, children, that the pressure acts in. Point number 2, pressure increases with depth. So if pressure is increases with depth, and that's why if we suppose we are in a river and more at a more depth, so our body will experience more and more and more pressure, more and more and pressure. Why our body will experience more and more pressure? Due to the weight of the liquid, weight of the water molecule above me, more and more. If I move downward, so more and more pressure my body will experience, because I can explain this point with the same explanation here. Now at this point, children, at this point I'm here, so above this point, how much water is there? This is the amount of water. Water molecule has some mass, it has some weight. So at this point, suppose this point A, at the point number A, above this I have some water. But if I take C point, that C point is at the bottom of the container. At C point now, how much water is there? This entire water. The entire water is there. So this water is exerting a force on me on the point number C, and that's why we can say at point C that the pressure is higher. So basically, here what I mean by this statement, children, that if I am here, suppose I am standing here, I will experience nothing. Only the atmospheric pressure is acting on my body. If I stand on the surface of the water, my body will experience the normal pressure, that is the atmospheric pressure. Children, we will discuss in our coming classes. But if I am here, second position, I am here, children, at this, my body will experience more pressure, because above, remember, I'm inside this water, children. Okay, I'm inside the container, inside water, like a swimming pool, like a river or a lake or a pond, or maybe seawater. And then if I'm here exactly at the bottom, and in this situation, that the entire water above me is exerting a force where on my body area, and that's why the pressure is force divided by area. More and more force will be there, because the water, more and more water is above me in that column, and that will make higher and higher pressure. So that is the explanation for this point, children, that pressure increases with depth. And third point, pressure depends on the density. As I told you earlier, children, density. So you can make a relation that P is directly proportional to density. It depends on density. Pressure depends on the density of the liquid. And if I take liquid, means water has different kind of density. Means if I try to, I'm in a container, this is a container filled with water, and I'm here underwater. So water exerts different kind of pressure, because water has different density. But if I replace the water with mercury, and if I am inside mercury, means if I place object inside mercury, so the mercury has higher density or lower density with water, children? Charvi, Arjun, if I replace water with the mercury, so mercury has higher density or lower density compared with water? Are you here, students?
Yes, sir.
Then tell me.
Yes. Here is
denser. Yeah, mercury density is higher. These things, children, you have to keep in mind. Please remember, density of mercury is higher than the water. And if that is the case, then it means in mercury, my body will experience higher and higher pressure. So remember, density, pressure is proportional to density. And even later on that you can discuss further, that density is also mass divided by volume. So you can also apply some concept of that. And the next point, number 4, pressure doesn't depend on the shape of the container, children. Shape means pressure is independent. P is independent of what? Independent of shape of container. Shape of container. This is a paradox actually, children. And if it is independent of shape, means I have 4 containers, different shape container, different diameter, but the water is filled at the same height, children. Water is filled at the same height irrespective of their shape, but the height of water is same. And if I take the, I have placed 4 points here as per the this picture. A, B, C, D are at the same depth, are at the same height. Okay, so at point A, pressure will be same. P means at P, B pressure will be same. At P, the pressure will be same, and at point D, the pressure will be same. Means I can say that PA, PB, PC, and PD all are equal. That is the paradox here. Pressure doesn't depend on the shape of the container, but it depends on the height or depth of the container. If we keep the same height, then the same pressure will act at point A, B, C, and D. And what I mean by this statement, children, that if you make a hole, very small, a very fine hole at point A, at point B, at point C, and at point D, then you will find that the water will come out, water will eject, and but with the same pressure, with the same will be the range. It will fall at the same, same. It will cover the same horizontal distance from the point of ejection. That you should remember this point. Another things about this pressure, okay, calculating pressure in liquids. Okay, children, that I want to discuss very important equation that we know pressure is force divided by area, and we have another equation, very important equation, children. Many questions of pressure you can solve with this equation. Pressure, please make a note it down in your notebook, children. Pressure is also equal to, what is this row, this letter, first letter, what is this, children? Hyunro. May I know what is this first letter here before G? What is this? Tanzim. Rajat, you tell me, what is this letter before small g? Rajat Gupta.
Yes, sir.
May I know what is this letter here? This letter I'm talking about. What is this?
Is it density?
Yes, this is density, children. This is density. So if you are not aware, if you don't know, so now please remember, this is density. Yonro said it is density. Very good. So this letter is density, and don't confuse. It is a italic form. It is like this. Remember, children, there is a difference in P. P is a straight P, pressure, but when you find this in italic form, it's a Greek letter rho, R-O-W. That is for density. Don't confuse with it. It is density of wet water, density of material actually. So please remember, this is density. Even you can write D, G, H, then this D is again density. But please don't get confused. Don't consider it momentum. Don't consider it pressure. But this first letter, this is rho, which is the density of that medium. So I'm looking at this equation, children, that rho gh. So let me write again. Pressure is equal to force divided by area, and I know I can write force, that is weight. I have this container, that look at this on the right hand side, this figure, and here in this image we have a container filled with water. It has some area, it has some height, and so it has some, the water is there, so water has some mass, water has some weight, and that weight is given by m into g. So mg divided by now, children, mass. I know very famous equation that we have studied in the chapter number 1, density. Suppose let me write D. Density is given by mass divided by volume. Can you recall this equation, children, from the chapter number 1? Density is mass divided by volume. So if density is mass divided by volume, so I can write volume. What is volume actually? Volume of this cuboid actually, LBH. And then mass, I need mass. So mass will be density multiplied by LBH. Let me write here, this M is equal to LBH, means volume multiplied by density actually. Volume multiplied by density. So I can further, want to replace this M with LBH, means volume multiplied by gravity divided by area. Area, what I can write, area L cross B, means length cross breadth. Any two values, L cross B will be cancelled out. So HG, one factor I have not written. Yeah, this D should also here. So D, H rho G. So we have this equation. So I derive this equation from the equation of pressure force divided by area. In exams, you have to use all this part depending upon what equation is given, what information is given, what numerical values are given, what quantities are given. So depending upon the situation, children, you have to solve simplified questions for your paper number 2, subjective paper actually. So remember, children, pressure is H rho G. So if pressure is H rho G, means pressure is also depending on now density. Pressure is also depending upon gravity. Pressure is also depending upon height. Pressure is also, from the previous equation, pressure is also depending upon force by keeping area constant. Pressure is also depending upon area of cross section by keeping force constant. So all these factors, children, you have to remember. There's only one factor in which pressure is in direct relation with area. Otherwise, we have pressure directly proportional to density, gravity. So it means gravity, pressure is depending upon the value of G. So it means pressure will be different at the different places, children. If I move upward, if I start moving upward, children, if I start moving upward, so the gravity value start decreasing as I move upward. So it means the pressure will decreases. So that's why the pressure at the ground is different, and the pressure at the highest mountain, we have the Mount Everest. If I consider Mount Everest, if you go to the Mount Everest, children, so the pressure will be different. Why the pressure is different, children? Because the density of air molecules decrease as we move upward. These are the basics that why the pressure is different, why the pressure changes as we move upward, because air density decreases. In this relation, G is different and the density of air also decreases. So these are the things that you should remember. And similarly, equation of pressure will be depending upon the density. Means if you are in sea water, underwater in sea, your body will experience different pressure. If you are at the same depth but not in ocean but in a lake, in a river, your body will experience different pressure. Why? Because seawater has different density. In seawater, that the salt is there, okay, but in the river the salt is not there. So depending upon the density, your body will experience different pressure. So please remember all these points. These points will help you in solving multiple choice questions for your paper number 1. And let me pressure is rho GH. Okay, there is one question, children. I want to discuss this question, then we will end our class. If the density of water is 1000, what is the pressure due to the water at the bottom of a swimming pool 2-meter deep? Please do, children, and tell me the answer. Answer is already there, but I want you do this question by yourself. Density is given, pressure you need to calculate. Where children? At a height is given. Means height means that the depth is given. We are talking about we are underwater, so depth. So height is given. Rho GH you have to put. Density is 1000. G you will take 10. Depth is 2. This is 20,000 Pascal. So this equation is valid, children, for when we are underwater. And you can see the heading of this topic. What was written? Actually, the heading was pressure in liquids. Pressure in liquids. So pressure in liquids at a certain point, at a certain depth, if you find this submarine is suppose at a depth of 500 meter. Submarine is at a depth of 500 meter, and you need to calculate how much pressure is acting on this submarine. So you can calculate, children. Or suppose if a diver is there at a depth of 100 meter, you can calculate how much pressure is acting on the body of a diver. How would you calculate, children? Height already given, means depth is given, g, that is 10, and what other factor? Density, depending upon, we are talking about water, we are talking about seawater, we are talking about whatever the density is given. Accordingly, you can find out the pressure acting on different object under water. So this worksheet, this exercise is also for your homework, children. Try to do question number 1, question number 2, question number 3, and if there is any problem, so please remind me in the next class, or you can WhatsApp message me so that I can send the solution. Now, children, I want to stop here this